Hello students. Today we are going to study second part of our class 10th science NCERT textbook of chapter number 11, that is the human eye and the colorful world. In the previous session of this chapter itself we studied two topics, that were human eye and accommodation of eye. Now in today's session we are going to cover eye defects and a little about refraction, the basic introduction about refraction. So what are the eye defects? As we studied that in the previous session we studied about human eye, the components, the parts of the human eye, internal structure of the human eye, and the accommodation of eye, that whenever we for seeing far off objects to see nearby objects, what is necessary. Now let's study about the eye defects. First eye defect is myopia. Myopia is short-sightedness. It is a defect in which a person is unable to see far off objects clearly but can see nearby objects. Even I am a myopic person, that the person cannot see far off objects clearly. Far objects they cannot see clearly. They can see, it is not like that they cannot see at all. They can see but not that much clear, but they can see the nearby objects clearly. So what is the cause? Why myopia is caused? What is that reason behind that? The muscles, the ciliary muscles which are present, they do not relax properly. As we studied in the accommodation of eye, that to see far off objects, the relaxation of muscles should be proper. The ciliary muscles should properly relax, so due to which the lens will elongate properly. But here the person who is suffering from myopia cannot see the far off objects. Why? Because the muscles do not relax properly and the lens do not elongate properly, due to which their focal length also do not increase, and so that's why no clear image is formed. So the eye defect is this. We saw the cause, the reason that why myopia is caused, why the person cannot see far off objects clearly. But what is the eye defect? What defect it causes in the eyes? The eyeball being too elongated, the eyeball becomes very long and the converging power of the lens become too high. So that's why the converging power becomes very high, and due to which the image is formed in front of the retina and can't be identified by the brain. As we know that the image formed on the retina, brain identifies that image and gives a signal, but here the image is formed already in front of the retina. So how will the brain recognize that image? So that's why the brain is unable to recognize. So the image is not recognized by the brain. So that's why because the converging power of the lens is too high. Now how can it be corrected? So by using spectacles containing concave lens. As we saw here in the eye defect, that the converging power of the lens is becoming very high. So the convex lens, so we can say that the convex lens power is becoming very high. So for correction, it's obvious that we need to use concave lens. So by using the spectacles containing concave lens, that diverges the ray. Convex lens converges the ray and concave lens diverges the ray. So by using concave lens that diverges the ray first, so that our eye lens can converge them properly on, so that our eye lens can diverge them properly on the retina, so that the rays gets diverged and one of the ray, or we can say some rays, fall on the retina, which can be identified by the brain. I hope that I am clear to you. Now another is hypermetropia. In myopia we saw that person is unable to see far off objects clearly but can see the nearby objects clearly, and then what is the reason behind myopia is the muscles do not relax properly, due to which the lens do not elongate properly and the focal length do not increase. So that's why no clear image is formed. That is the reason behind myopia. And the defect which eye causes due to myopia is the eyeball becomes too large, due to which the converging power of the lens also becomes very high, and that's why the image is formed already in front of the retina, which the brain is not able to recognize or identify. So how can it be corrected? It can be corrected by using concave lens that diverges the ray so that some of the rays fall on the retina and could be identified by the brain. Now let's study about hypermetropia. Hypermetropia is long-sightedness. Long-sightedness means it is a defect in which the person is unable to see nearby objects clearly but can see the far off objects clearly. Now, what is the cause for this? It's simply opposite of myopia. In this, the ciliary muscles do not contract properly and the lens do not become thick and short, so due to which the focal length also do not decrease. It's just simply that you have to just refer to the accommodation of eye, the topic which we learned in the previous session, accommodation of eye. So as a result in this, the image formed is not clear and it is not identified by the brain. It's just simple. In case of hypermetropia, the reason behind hypermetropia is the ciliary muscles do not contract properly, and that's why the lens do not become thick and short. And so in case of myopia, we saw the lens do not become long, and in case of hypermetropia, the lens do not become short, and due to which the focal length do not increase. As we saw in the case of myopia, the ciliary muscles do not relax properly. In case of hypermetropia, the ciliary muscles do not contract properly. In case of myopia, we saw that the lens do not elongate, do not become long. In case of hypermetropia, the lens do not become thick and short, and due to this, in case of myopia, the focal length do not increase, and in case of hypermetropia, the focal length do not decrease. So that's why the image is not formed clear in both the defects, and that's why it is not identified or it is not recognized by the brain. Now let's study the eye defect. Eye defect, that the defect which eye causes is the eyeball becomes too short. As we saw in case of myopia, the eyeball becomes too long, and so that's why in the case of myopia, due to the elongation of the eyeball, the converging power of the lens becomes very high, and in case of hypermetropia, due to the shortening of the eyeball, the converging power of the lens becomes too low, and due to which the image is formed behind the retina. In case of myopia, the image was formed in front of the retina, which was not recognized by the brain, and in case of hypermetropia, the image is formed behind the retina, that is also not recognized by the brain. So how can it be corrected? By using spectacles containing convex lens. In case of myopia, we used concave lens, and in case of hypermetropia, we need convex lens that increases the converging power of the eye lens, and so that it converges the rays properly on retina. As we know that convex lens converges the rays and concave lens diverges the rays. So in case of concave lens, the rays are diverged so that some of the rays should fall on the retina, or some of the rays should fall on the image, which forms the image on the retina, which is recognized by the brain. And in case of hypermetropia, convex lens are used that increases the converging power of the lens so that it converges the rays and the image is formed on the retina, and so that's why that is recognized by the brain easily. I hope that I am clear. Now let's see another eye defect, that is presbyopia. Myopia and hypermetropia are simply opposite to each other. Presbyopia is with gradual increase in age, our ciliary muscles like other muscles weakens. As we know that as our age increases, the muscles which are present in our body weakens. So in a similar way, the muscles which are present in our eyes, the ciliary muscles, also weakens. That is, they can't even contract or can't even relax properly, and as a result, person can't see nearby objects, neither it can't see far off objects clearly. So how can it be corrected? It can be corrected by using spectacles containing bifocal lens. That is, both the spectacles which contain both convex and concave lens, that are known as bifocal lens. So with the use of bifocal lens, this defect can be corrected. As we can see that in the upper case, here in the inside part, concave lens is used, and in the upper part, convex lens is used. So I hope that I am clear with presbyopia. Presbyopia is just with increase in age, our ciliary muscles like other muscles in our body weakens, and so that's why the person is unable to see nearby and far off objects clearly, because the ciliary muscles can't contract neither relax properly, and it can be corrected by wearing bifocal lens. Now, what is the advantage of having two eyes? Why do we have two eyes? So first is to increase the horizontal view. If we have only one eye, or if we can't move our eyes, we can't see the horizontal view. Only vertical view can be seen through that eyes. But to increase the horizontal view, we have two eyes, and another reason is that two eyes are separated by few centimeters. As we can see that there is a distance between the two eyes. It is because to increase our ability to judge the depth. If we want to see any figure or any object in depth, so this distance increases our ability to judge the depth of any object. This is called as solipsis. Now, what is our far point and near point of human eye? The far point is infinity, till whatever we want to see we can see, and the near point is 25 centimeter. Below 25 centimeter we can't see any object. You will say that I can see an object which is kept below 25, which is kept near to me below 25 centimeter. Yes, you can see, but the image of that object is not that much clear that you can recognize that what the object is. You can see, but you can't identify the object. Okay, now let us do some numeric problems related to this. So, first, the far point of myopic person is 80 centimeter in front of eye. What is the nature and power of lens required to correct the problem? So, far point of myopic person is 80 centimeter. Means we are given with the far point, that is our focal length. Focal length is 80 centimeter. Myopic person means the person is myopic. So, to correct that eye defect, to correct the myopia, which lens is required? Obviously, we require concave lens. So, the nature of the lens is concave. So, one question is solved. Now, we have to find out the power of the lens. How we will calculate the power of the lens? Power is equal to 1 upon focal length in meter. Here we are given the focal length in centimeter, so we'll convert it in meter, that is we'll divide it by 100. So 1 upon f, that is 100 is, it is converted into meters, so we will divide minus, and one more thing, we will take it minus 80 centimeter. Why? The focal length is taken minus 80 because the image is formed in front of the retina. The image of a myopic person forms in front of the retina. So that's why the focal length used is minus 80. I hope that I am clear to you. So the power is equal to 1 upon F, which is in meter. So if we convert centimeter into meter, we will divide 80 by 100. So 100 into 1 upon minus 80, that is minus 1.25 diopter. Power is always written in diopters. The SI unit of power is diopter. Now another question is, a person needs a lens of power 5.5 diopter for correcting his distant vision, that is minus 5.5 diopter, because obviously it is a distant vision, means far off objects, that means myopia, right? And for myopia the image is formed in front of retina, so that's why the power will be in minus. So for correcting his near vision, he needs a lens of power 1 plus 1.5 diopter. What is the focal length of lens required for correcting distant vision and near vision? Now see, here we are given with power. Power is given and we have to find out focal length. So first, power for distant vision is minus 5.5 diopter and for near vision is plus 1.5 diopter. So let's calculate first the focal length of distant vision. As we know, power is equal to 1 upon focal length in meters. So P is equal to, for distant vision, power is minus 5.5. So here we will write down minus 5.5 diopter equal to 100 upon F. 100 upon F. F we have to find out. So F is equal to 100 divided by 5.5. So 5.5 will come here and here 5.5 will come here and F will go here. So 100 upon 5.5, the point is removed, so that's why one more 0 is added in beside 100. So our answer is minus 18.18 centimeter. That is the focal length. Our focal length we are finding in centimeters, so that's why we have taken here 100. If you want to find out in meters, then you can keep 1 here as it is. Okay, now we will find for near vision. For near vision, P is equal to 1 upon F meters. We will find in centimeters. So P for near vision is plus 1.5 diopter. 100 upon F. F will move here. F will move here and 1.5 will move here. So point is removed, so one more 0 added beside 100. So 1000 upon 15, that is 66.66 centimeter is the focal length for near vision. I hope that I am clear to you with this numerical. Now another numerical is, the near point of hypermetropic eye is 1 meter. Now there comes the case of hypermetropia. What is the power of lens required to correct his defect? Assume near point of eye is 25 centimeter. Near point we have to assume 25 centimeter. We have to find out the power of lens to correct this defect. The near point of hypermetropic eye is 1 meter. Now let's calculate it. So as we can see here that the near point of hypermetropic eye is minus 1 meter. So we are given with the near point, so that's why we'll give the sign negative, that is minus 1 meter. We'll convert that in centimeter, which is minus 100 centimeter. That is our V. That is V means final point. P we have to find out, that is power of the lens we have to find out. U, near point we are given is, assume near point of eye is 25 centimeter. Here we are given. So U, our initial point is minus 25 centimeter. So first of all we will find out the focal length, because P is equal to 1 upon F. So as we know that 1 upon F is equal to 1 upon V minus 1 upon U. So 1 upon minus 100 minus 1 upon minus 25, which gives us F as 100 by 3 centimeter. So here we get the focal length 100 by 3. Then power is equal to 100 upon F, that is in meters. we have to find it in meters, and here we are given the focal length in centimeters. So we'll divide it by 100. So 100 upon 100 upon 3. So this 3 will go beside the 100. So 100 into 3 upon 100. 100 cancels. So we have the power plus 3 diopter. See, we got the power of the lens which is required to correct this defect is plus 3 diopter. Now we will see refraction through a prism. This is just the basic, the introduction. I am introducing the topic refraction to you. Detailed study we will study in the next session. Refraction through prism. Prism is a piece of glass or any transparent material which is bounded by triangular and 3 rectangular surfaces. As we can see here, the prism is given. This is a prism. It looks somewhat like this. This is a this is how a prism looks. So it is a piece of glass or any transparent material. It is bounded by triangular. This is triangular and 3 rectangular faces. It has 3 rectangular faces. That is, we will see here. This is one rectangular face. This is another rectangular face, and this is the third one. Okay, so here you can see that 3 rectangular faces. Now the rectangular surfaces are called refracting surfaces. We call these rectangular surfaces as refracting surfaces. One, second, and this is the third one here. Third, this. Okay. Now the angle between 2 refracting surfaces is called refracting angle or angle of prism. The angle between 2 refracting surfaces, that is this angle. This is the angle, this is the angle. Here this is the angle. The line along which 2 refracting surfaces meet is called the refracting edge. And any section of prism which is perpendicular to refracting edge is called principal section of edge. The line along which 2 refracting surfaces meet. Here 2 refracting surfaces meet. This is the edge. These 2 are the edges. Okay, so now let's see now refraction through a prism clearly. As if suppose this is the refracting ray, a ray is coming, light ray is coming. So from here, this is the ray which is incident to that ray. So this is the angle of incidence, which is denoted as angle I, small I. Then from here it passes and it refracts this way. So if from another angle which is formed here, another light ray which refracts, here we got the light rays passing. So here an incident ray passes. So this is the angle of incidence. Here the light ray refracts. So here a refracted ray comes. So this is the angle of refraction, or we can say here it is emerging. So we can say this is the angle of emergence. Here the incident ray and the refracted ray emerges. So this is the angle of emergence and this is the angle of refraction. Okay, I hope that I am clear. See, I am taking it once again. A light ray is passing, a light ray is coming, and it what we say, it stop or it binds, it passes through this prism. Okay, then here an incident ray comes. So this is the angle of incidence. Then here it passes through the prism and the light ray refracts. So here a refracted ray comes and this is the angle of refraction. And here the two rays, the incident ray and the refracted ray, emerges. So this is the angle of emergence. I hope I am clear to you. With this, we complete our today's session. If you have any doubts, you are free to ask. In the next session, we are going to have a detailed study about refraction and dispersion. Thank you and have a great day.